Hey everyone, today I want to talk about context engineering and how context engineering can make your AI applications better and help you create value for your customers. The content is specifically designed for product managers who are building AI applications for their customers. The large language models have a problem. Large language models are very powerful, but they do not have your organizational context. For example, they don't have access to documents such as contracts, risks, policies, specifications. These things are invisible to an LMS, to an LLM. Without context engineering, answers from an LLM may be too generic, incomplete, or sometimes even wrong. Now, context engineering is the opportunity for enterprise software companies and AI product managers because enterprise software vendors can provide context to LLMs to help them provide organization specific answers. Now, this is a huge value for customers. Um, it's also an opportunity for another reason. AI software companies can differentiate with context engineering, because they cannot compete with these state of the art large language models, but they can differentiate with context engineering. Why? Because a large language model, such as OpenAI's models or Anthropic models, will never be allowed to access content that is specific to an organization. Even if they want to, no organization will let them do that. So this is a huge opportunity for enterprise software companies, and because of that, AI product managers need to absolutely take advantage of this. And to take advantage of it, you need to understand it. So, what is context engineering? Context engineering is the practice of giving AI an index of your organization's content, just like an author would add an index to a book. If you're looking up some specific information, you go to the index, you look at the index, and then immediately go to the specific page or pages where that index is pointing to, and get your answers quickly. The same way an index helps a reader of a book access information quickly, even if the book is 1,000 pages long. Context engineering will help AI jump directly to the right page or pages of your organization's content and retrieve a precise and very relevant answer very, very quickly. So, how to engineer context for your AI applications? You may have listened to your engineering colleagues talk about, oh, we parse the content, we chunk the content, we create embeddings, and then when a user asks a question to your AI agent or your AI application, we provide those chunks to the LLM and get very, very specific answers. So we are going to understand, we are going to look at the tools and see a hands-on demo of all these things. We will understand what this means conceptually, and we'll also see how exactly you can do all these things, how to parse, how to chunk, how to embed, and how to retrieve a right answer. So that's what we are going to do. So the first thing is parsing. So what we are going to do is we are going to take the US Constitution, which is a large document. I'm going to get a PDF file and parse that document. Parsing is the process of turning a very poorly formatted document and um, reformatting it so that a machine or a large language model can read that document easily and without any confusion. So that's what we are going to do. So Playground, I'm going to upload a file, click a file and drag it here. I'm going to open the file constitution.pdf. For the purposes of parsing, I'm using Llama Cloud, and it has a parsing. It has parsing capabilities. So just click on parse, and the parsed file, which is which will have a format, which is also called a markdown file, which will have a format that is very clean and very readable by a machine. So rather than a PDF with a lot of images and formatting, this one is a simple parsed file, and now this file is available. So I am going to download this file and then go to the next step, which is chunking. Chunking is breaking a large file. Sometimes a document is 1,000 pages long, and if an LLM is asked to read that entire document and say summarize it or answer a question, it may, first of all, it may take a lot of time, and the second thing is it may give a very general answer and not give a very specific answer. You may be asking for cancellation policies in a contract in the context of a particular section, and it might give you an answer about a cancellation policy from another section. So, for that reason, you need to chunk them into meaningful chunks, chunk the document into meaningful chunks, so that you can just give the relevant chunks to it and say the answer is most likely here, get the answer. So that is the purpose of chunking. So how do you chunk a document? And let's say in this case, we have the markdown file of the US Constitution. And how do you chunk it? Now, there is no standard point and click applications available for chunking, to the best of my knowledge. So I wrote an application that will not only help you chunk a document, but also explain the concepts of chunking. So the app is starting, and once it starts, we can upload the Constitution Markdown file and chunk it. So here it says upload your Markdown file. So we are going to choose a file. Constitution.md is the file. And while chunking, you can decide how big each chunk should be. And here I'm going to define each chunk in terms of words. I'm going to say each chunk should be 500 words. And then there is a concept called overlap. I'm going to choose 100 for words and 15 for overlap. The concept of overlap is when you chunk a document, you allow a little bit of overlap between the first chunk and the second chunk, so that a particular sentence or a concept or a diagram or a table is not cut off abruptly. So you allow a little bit of overlap, so that the LLM can make sense out of it without getting confused. In general, providing some overlap enables the LLM provide you with a better answer. That's the purpose of doing it. Now, these are also parameters that an AI product manager can play around with. Should it be a 100-word chunk or a 500-word chunk or a 2,000-word chunk? Should the overlap be 15 or should it be 40? So these are things that you can play around with to increase the quality of your responses from the LLM. So here, I'm going to say 100 100 words per chunk, and the overlap I want it to be 15. So it immediately says each chunk will contain approximately 100 words and 15 words overlapping from the previous chunk. Overlap percentage is 15%. So this tool gives all that information to me. So I'm going to say process file, and it should give me about 100 plus chunks. So yes, it has created 107 chunks, and the chunk size is 100 words are tokens, and overlap size is 15 words are tokens. I also built a capability to preview each chunk. So for example, if you look at this one, this is the first chunk. You can go to the second chunk. The entire constitution has been broken down into small chunks, and I can also see if that overlap is working. For example, here it says excluding Indians not taxed 3/5 of all other persons, and it should be on the next chunk as well. So for example, here the excluding Indians not taxed 3/5 for all other persons. things like that. So the chunking is working, the overlapping is working, and now we can download this as a .zip file. And the next step is to um, take this information that you've chunked, which is a collection of markdown files, .md files, and then turn each chunk into a vector. A vector is a series of numbers which contains a semantic fingerprint of meaning. Now, what that means, it sounds pretty abstract. What does that mean? I mean, that is where I again, there was, to the best of my knowledge, no standard application that will that creates embeddings. Your engineering team will do this via code, but there was no point and click application to do that. So I built an application that will do that. So this is okay. This is a chunk. What I need is the yeah. I called it embed genius. Basically create these embeddings from the markdown files that you just chunked. Once it loads, we can upload the file. So here you upload the markdown file .md files or zip. In this case, I have a constitution chunks.zip file. I'm opening that constitution chunks.zip file, which is a collection of all the 107 .md or markdown files, and then there will be a manifest file as well. So I upload all that and say, now process all these things and create embeddings, sometimes also called vectorize these files. What that means is convert all these files into a series of numbers so that the LLM can read and understand the fingerprint, the semantic fingerprint, the relationship between say certain words. For example, if you say a senator and then another chunk has a phrase called elected government official, um, vectorization will help the LLM understand that senator and the elected government official are likely the same or likely connected or closer, things like that. That's what I mean by a semantic fingerprint. So I'm going to say process files, and now we should get um, an embedding for every markdown file for every chunk. So let's see, we say process files, and here for every chunk that we created, there is a preview of the chunk, the content of the chunk in plain English, and then the semantic fingerprint, which is a series of numbers. It'll be a long series of numbers. In here, it shows only the first 8 values, just to give you a sense of what that embedding will look like. So here are all these files, and so for example, if we, what does this mean? Yes, this is nice, but what is the purpose of this? Now, if we search for, say, senator, the word senator, let's say in the case of a chat bot, or in the case of a search, if you search for senator, it should ideally give back just the chunks that have the word senator or have a word or a phrase that is closer in meaning to senator, right? So for example, let's see. Okay, yeah. So it returned 3 chunks, saying that, hey, there is a good chance that these 3 chunks are the ones that are relevant. Now, what your prompt or your enterprise application will do, your AI application will do, is take these chunks and then give it to the LLM and then get the information back. And the information, the result that comes from the LLM will be relevant to your organization's content. So that is context engineering. I hope that helps.